Welcome to the UGC lecture series. This is the E-PG Pathashala lecture series, in which we will be talking about the course data structures, with a view perspective of abstract data types. In the previous two lectures, we had spoken about abstract data types in general and the list ADT or abstract data type. Today, we are going to look at the one particular implementation, one type of implementation of the list ADT in detail. So, what are the learning objectives of this module? We are going to discuss the different implementation of the list ADT. We are going to understand array and array based vector implementation of list ADT, and we are going to outline the implementation of list using dynamic arrays. Now, when we are talking about this course on ADT based data structures, we should remember that the implementation is very much dependent on the type of operations associated with that particular list ADT. That is the underlying idea you should always keep in mind. So, now let us look at the implementation of an ADT. Now, when any ADT, when we want to implement an ADT, choosing the data structure to represent the ADT's data is a part of the implementation and a very important part of the implementation. So, choice of the data structure depends on what are the operations that ADT does and the context in which the ADT the operations will be used, and also the frequency in which the operations will be used. So, implementation details should be, as we already know and has stressed in the last two lectures, should be hidden behind a wall of ADT operations. A program would be able to access only the data structure and will be able to access the data structure using only these particular ADT operations that has been specified for that particular ADT. Choosing a data structure to represent the ADT, as we already told you, is an important aspect of the implementation. So, you can choose to represent it as arrays, records and so on. Each operation associated with an ADT is implemented by one or more subroutines, and of course, the two standard implementations for the list ADT are array based and linked list. So, static implementation of the ADT list. The simplest method to implement a list ADT is to use an array, because basically the array and the list have a same connotation or same concept behind it. So, because it is a linear list, it is a contiguous list where the elements, the array is a linear list by itself, it is a contiguous list where the elements are stored in contiguous memory locations, array positions or other words. So, it will use an array of a specified maximum length and store and the store is allocated before runtime, that is, it is a sequence of n elements that is allocated before runtime. So, it orders the elements in the array with an index related to the position of the item in the list. So, the index is used, index to the array is used, and in each index you will store the element that is depending on the position of the item in the list. So, this is the array implementation. So, array, the first thing when you talk about array is you are allocating contiguous memory locations that will be used, and an array is a viable option for storing list elements, because fundamentally, as I told you, both elements are sequential. It is a commonly available data type and algorithm development is very easy. So, this would be the implementation, first element, second element, this could be the list. This is the empty locations allocated to the list, but not filled. This is the current location and you can have n plus 1 and this is the maximum length. So, for implementing this using arrays, we need the array for storing the entries, which we will call as list array. We need a variable to keep track of array elements assigned to the list, that is current will tell you how many elements are there and so on. The number of elements in the list or the current size of the list. So, that will be represented as size, and a variable to record the maximum length of the array, how many elements can be stored on the array, and that is actually going to be the size of the list and it is called maximum size. So, these are the many these are the different aspects you need to know and the variables you need to use for implementing lists using arrays. Now, let us look at the static implementation of ADT list, that is the array implementation. So, this is the size n, this is the elements list array, this is the whole array list array, this is an unused this thing. This is the, you can make current point to any element in the array. We have stored m elements here, and this is the list array, this is A1, A2, A3, and this is the maximum size allowed. So, this is unused. Remember, this whole thing has to be allocated at before runtime. Okay, that is the major aspect here. So, now let us look at how to implement the list using this representation of the list. Now, what have we done at this stage? We have chosen, okay, I am going to represent the list using an array, which is a static implementation. Why are we calling it that? Because the memory is allocated well beforehand. What is the size of the memory we are allocating? We are allocating some maximum size that is not equal to the length of the array. The length of the array will be less than the maximum size, but the array can grow only to that extent. So, what we do? We fix one end of the list at index 0 and shift as needed when an element is added or removed. Insert and delete will take 0 end time. Now, here is the crux. You insert at position 0, making a new element requires first pushing the entire array to the right and one spot is made to make room. If you want to delete at position 0, you have to require the shifting of all elements in the list left one spot. Now, this is the crux of the implementation, which means this is the most time consuming aspect of the implementation. So, then what is this is the price you pay. For what do you pay the price? You pay the price because once you know the index, you can just directly go and access it because of the contiguous allocation and the sequential allocation. So, before we do the implementation, we have to do an initialization. So, how do we do the initialization? We declare the array of list items with maximum number of items equal to n. So, you have to declare the size of the array, then requires an estimate of the maximum size of the list. This is the waste. So, suppose you allocate 1000 memory locations for this list and you are using 100 only, but still 1000 is allocated and it is a waste of space. So, this allows you to grow the thing, but if you that is an overestimate. Now, suppose you make an underestimate, then you cannot go beyond a particular size. So, this is a problem. So, initialize the list with the number of items. Initially, the number of items is going to be 0. Now, finding the first element. Now, this is a simple operation. So, you if the number of items is 0, it will give yes and return false. No means the element at the first location is returned and a boolean variable is assigned to set to true. So, returning the first element if it exists, this is the definition we are giving. We can give any definition, it does not have to be a boolean variable. Here we are using first as a, we are defining first element to be a boolean variable, which will return a value false if there is no first element or the number of items is 0, or it will return the first element and give a value of true. It is only that we are defining it like that. Remember, an ADT list has to have a description of what that list ADT is and the operation. When you are talking about the operation, you will define first in this way. So, I am setting boolean variable to true if it is that is the first element, otherwise if it is empty, it will set the boolean variable to false. So, now the list implementation using arrays. So, let us look at insertion. Now, this is interesting. So, what happens if you want to insert an item at the specified position in the existing array? The item originally at the given index must be moved right one position and all items after that index must be shifted. So, suppose you want to insert 2 here, all 5, 10, 7, 12, everything has to be shifted right one position. In this example, we have shown only 4 elements being shifted, but if the size of the array is 100 and you want to insert the 101th element in the first position, you have to shift all the 100. That is the crux that you have to understand here. So, let us look at an example. Suppose you want to insert the element k in the third position. So, this is the index or the point of insertion. K is the element to be inserted and list is the list in which to insert. So, this is the original list. We are starting the list starting from 0. Some places they start with 1. It does not matter. Why we start with 0 is because most arrays are represented with 0 2. So, here we have 0. So, what we want to do is we want to insert k at this position k. Now, this is not an ordered list, this is an unordered list. Yeah, this is an unordered list. So, we are defining where to add by telling the position at which you want to add, which is 3. Okay. So, that is the fourth element or in the third position. So, this is the original list. Now, before I start any insertion for any data structure, I have to first decide whether the maximum size allocated to it has been exceeded. So, that is the first thing we will do, that is I will be using pseudocode to explain the algorithms to you. So, we have set a maximum size. In this case, because it is an array implementation, we have associated maximum size is the maximum size allocated for this array before runtime. So, if it is greater than maximum size, if the existing size of the array is all greater than or equal to maximum size, then means there is an error. So, that is what you will indicate. Now, if it is not, then we have to do the first step, which is shifting right. So, what we do is from this position onwards, from the third position onwards, we are going to shift to this position. So, what we are doing is here we are doing a loop. What loop are we doing? Loop till current item index plus 1 is equal to items index. So, the item at index plus 1. Okay. So, the current here will be at this position, that means the maximum size, the current size of the array, though the size is 7, the index is 6. So, what we do is the items at index plus 1 is made equal to the item as x, the items as index plus 1 is equal to the item at x, and so on. So, you will just shift these elements one position here. So, this is the loop you will do, this is the shifting, right. Then what you do is, now you have got a position, bare position, where you can insert the element, that is the third position at which you want to insert the element. So, the next step is writing into that gap. Okay. So, index of index is equal to k, items of index is equal to k, index is the index element, and then you have to increment the size as size plus 1, and you have to increment the current, which would have been pointing to, in that case 6 to 7 now. Remember, the size is 1 more than the actual index, because we are starting from 0. So, that those two if you do, you have finished. So, this is the pseudo code that we do. I will just go through it again. So, first you have to check the size, then you have to loop till you find the current position. You have to loop till the current position, you have to keep shifting, where current position points to the last element stored. Then once you have vacated that position where you want to insert, then you insert it, and then you implement, you increase the size and increase the current. So, this is a simple implementation, list implementation using arrays. So, deletion from arrays, what happens if you want to remove an item from the specific position in the array? Again, what you do? You cannot leave gaps in the array. So, indices that contain no elements, which in practice means that the array element has to be given a special value to indicate that it is empty. You can still do this without doing the shifting, but then you will be left with gaps which you have to give a special value. So, all items after the removed items must be shifted now to the left, the opposite direction. So, the deletion is like that. This now suppose you want to again I have indicated the position. So, you want to eliminate this. So, what you do is, this is the original list. So, here any deletion you do on a data structure, you have to check. In this case, we are checking the index. If the index is 0, less than 0, it means that there is no list, the list is empty. So, then you cannot do an element. So, you cannot do an insertion when anything is completely filled, size allocated. We will talk a little more about this in another implementation. We are talking about the array implementation. And deletion you can never do in any data structure, any implementation you can never do if it is an empty, in this case the list is empty. So, that is the first checking you do. Then after that we have to do the shift left. So, you loop until the index item, you have to put into the index whatever is in index plus 1. This is this 0 you put here, Q here, R here. Now, this L has been deleted. Now, in the next step what you have to do is update the size. So, the size becomes 6 and update the current will decrease by 1. So, this is what you will do in the deletion. Now, you have understood that in insertion and deletion, when you are doing insertion and deletion, the shifting is a costly operation. Here we have looked at 3-4 shiftings only, but that loop actually can be quite huge. As the size of the array increases, the loop time taken to implement, the number of times the loop is implemented becomes high. So, what are the good things about array based implementation? It is a fast random access of elements. So, you can access any element. If you know the index, you can access the element, which is a very great advantages. Memory is efficient, very little memory is required other than that needed to store the contents, and if you make a good estimate of the size of the array that can come, then this is a very good implementation. And the size must be known, that is what I was saying. When the array is created and fixed, array implementation of lists use a static data structure, and it has to be defined at compile time, and it cannot be altered when the program is running. This means we tend to usually waste time because we tend to make an overestimate. Now, the disadvantages are it is a slow deletion and insertion of elements. It also means that data must be added at the end. If you add at the end, there is no problem because no shifting is required. But if you want to add in the front or in the middle, there is this shuffling that you have to do, and so this is slow and inefficient. The same thing both for deletion and insertion. So, now let us go back to our list ADT. Now, what did we start with? We defined what is the list ADT, and we said that the operations can be different, and here we looked at a static implementation of the list ADT, and we said that and then we used an array and we said that what are the operations that can be done well and what operation cannot be done well. So, now suppose you see you have an implementation or you have an application where you need the list ADT, where always insertion or deletion happens only at the end, mostly 90% it happens only at the end, and but the most frequent operation is retrieval of elements from a position, then this particular array implementation is very good. So, it depends on, and that list ADT has those type of operations. The array implementation is the best suited to do that list ADT, which will be used in the application that requires that type of operations. This is the circle that we have to understand. Now, let us look at another implementation. This is again array implementation only, which is called the vector ADT, which extends the notion of the array by storing a sequence of arbitrary objects. So, element can be accessed, inserted or removed by specifying its rank. That means, the number of elements preceding it. An expectation is thrown if an incorrect rank is specified, that is you cannot tell a negative rank or you cannot tell a rank that is higher than the current size. So, this is like telling something like giving the position. Here we are saying it as rank, the rank position. Rank is the number of elements that come before the particular element. So, you are specifying the position, in other words here we call it as rank, to indicate where we want to insert or delete. So, the operations that you do on vector implementation of list is slightly different from what you do for the normal array implementation. So, you can give element at rank, that is returns the element at rank r without removing it, replace at rank, replace the element at rank with some element object 0 and return the old element. So, this is also possible. Insert at rank, here what you do? You insert a new element object or object O to have rank r. Remove at rank removes and returns element at rank r. So, now you see that the definitions are slightly different. One is it returns the element at r without removing it. So, this is just a retrieval process which we have seen in the general definition. Replace at rank, this is slightly different. What we are doing is we are taking an element that is, we are going to the rank r, replacing the element that is existing there, but we are taking out that element and returning it. You do not have to return it, this is just a definition, a new definition, and obviously the implementation will have to take care of that definition. Then insert at rank, you just insert a new element at r, all those shifting up, this is similar to the rank, the insertion using arrays. Remove at rank just removes the element and returns the element at r. So, additional operation as usual is size and is empty. So, some applications of vectors is sorted collection of object in an elementary database. Indirect application is auxiliary data structures that you use for algorithms, component of other data structures. So, vectors is used quite commonly. So, let us look at this array based vector. Use an array V of size n. So, you are using an array V of size n, a variable size, this is the size, keeps track of the size of the vector, the number of elements stored. Please note in both the cases the size of the array and the number of elements stored are different. The size is what has been allocated to it, okay, and size keep the track of the size of the vector size is n and the size keeps track of the size of the vector. This is the array. So, operation element at rank r is implemented at 0 1 time by returning whatever is available at V of r. So, that is a simple operation. In operation insert at rank r 0, we need to make room for the new element by shifting the elements like we did for the array implementation. So, in the worst case, if you want to insert at the beginning, it will take time 0 n if there are n elements. Now, deletion. Now, the deletion remove at rank r, we need to fill the hole left by the removed element by shifting backward the same way. There we shifted right, here we are shifting left the same way, and in the worst case when you want to delete at 0, you have to shift everything to the left. This is exactly what we described for the array implementation. So, remove at rank r and insert at rank r are similar to the insertion and deletion we did for the list implementation using arrays. Here we are doing the list implementation using a vector where we are specifying something called a rank. Now, the performance in the array based implementation of a vector, the space used by the data structure is 0 n or of the order of n. Size is empty, element at rank and replace at and run in 0 1 time. This is the idea. So, because look at something, some particular operation that is specified to specific to this vector representation of the list, where if you want to replace an element at a particular place by another element, that is you are removing an element and inserting another element, there is no shifting. So, it takes 0 1 time. See, insert at rank and remove at rank is similar to the insertion and deletion that we saw using array implementation. If you use array in a circular fashion, insert at rank and remove at rank run in 0 1 time. If you use it in a circular fashion, you do not have to do the shifting. In insert at rank operation, when the array is full, instead of throwing an exception, we can replace it with an array of a larger size. That is another methodology that we use. Now, let us look at the ADT list using dynamic arrays. Now, what is the meaning of that? Till now, both the implementation we saw, that is the array implementation and the vector implementation. Please note the difference between the array implementation and the vector implementation is marginal. Only the what we see, that is both are represented using arrays only, but in the vector we are defining certain type of specific operations and we are defining the vector to be something where we have specified something called a rank. So, we had replace at rank and retrieve at rank having 0 1, that is very quick. So, if you have those type of application, you can use this. Now, we are moving away from static implementation to a dynamic implementation, but still a dynamic array implementation. So, a dynamic data structure is one that changes size as needed as items are inserted or removed. There is usually no limit on the size of such structures other than the size of the main memory. You can keep on increasing the size, there is no limit. Dynamic arrays are arrays that grow or shrink as per the needs. New array is created when the old array becomes full by creating a new array object, copying all the elements in the old array into the new array and assigning the new array to the existing array reference variable. So, here the price you pay, as usual you have to pay a price. The price you pay is when an old array becomes full, you can create a completely new array double size. We will talk about the size later. Normally it is not just one increment, you will have quite a large. So, you create a larger array, copy everything from the old array to the new array and use this new array with a new reference variable as a new list. So, this is how it is done. So, the dynamic array, we will just look at how it works. So, this is an array stored, this is a dynamic array. As of now, it is only an array. This is the current position and this is the array it is stored in 0 1 2 3 position. Now, suppose I give insert 3, this is not doing any dynamism, it is a normal static array. So, I am very conveniently inserting only at the end. So, I have inserted at the end and the current becomes 5. Now, again I am inserting at the end. Here insertion, for our example, we are assuming that when we say insertion, it means insertion at the end. So, I have inserted 9. So, now what happens? Insert 9 comes. Now, my current is 6. Okay. Now, I am giving insert 2. Now, what happens? The array is full and there is no room for a new item. At this point of time, we will create a new bigger array. Okay. So, this array we have created, here we have just put one size. Normally, double is a way of creating. So, we create here, it is exactly not double, but still. So, now we give what you have to do, you have to take all the elements of the old array, all these elements and copy it into the new. So, we have copied. Now, the current is 6. Now, remember we did this because there was an insertion we had to do. So, finally, we do insert 2 into the new array and make current equal to 7. So, the old array will eventually be, that will be there, we have copied it from the old array, it will be eventually deleted. The question is, what is the price you pay? Now, here we are assuming it is only insertion at the end. So, what is the price you pay is you have to in the middle you have to allocate a bigger array and you have to copy all the elements of the old array into it and continue the process. What is the dynamic array? Before every insertion, check to see if the array needs to grow. So, before you do an insertion, you check whether the size has become full. Remember previously when the size was full, we just used to give an error. Now, instead of that, when the size is reach the maximum, we want to grow. So, when growing array, how much to grow? That is a question that is needed, and how much to grow memory efficient. If you do it by 1, what will happen? The memory is efficient, by the time What about the time? Every time you create a new array, you have to copy the old into the new. So, the time is not very efficient. So, it is as usual, it is a compromise between memory and time. So, if next time see once if you grow by 1, every time you want to insert, you have to create a new array copy, create a new array copy. But if you do I mean again here you have to make an estimation of how many you need, how many insertion you would need, and based on that. So, most probably they will do a double. Growing by doubling works well in practice, because it grows very large very quickly. So, 10, then you can make it 20, 20 becomes 40 and so on. Very few array resizings are needed in such a case, while the copying operation expenses, it does not have to be done often. So, in this implementation of lists using dynamic arrays, the most complex operation or the most time consuming operation is the copy operation, copying from the old list to the new list. Okay. So, while that is a costly operation, if you do this doubling, in practice they have found that this does not have to be done very often. So, but there are some problems in dynamic arrays also. What are the problems in dynamic arrays? When doubling does happen, it may be time consuming, and right after doubling half the array is empty. Resizing after each insertion would be very slow, because remember every time you resize by 1, you have to copy the old into the new, then do one insertion, copy the new into old into new, do a new one, and all the references or everything has to be changed. And deletion and insertion in the middle, here we have done at the end. Remember, we assume that all the insertions and deletion, we showed the example of only insertion. We assume that the insertion is being done at the end, but if you are doing in the middle, then as usual on an average you will take of the order of n. This is true for any array implementation. We saw in the initial array implementation, insertion and deletion in the middle was time consuming. In the vector representation, again an array implementation, array representation, static representation. If you want to insert, just do an insertion or deletion at some place, especially at the beginning or the middle, it took average of 0 n. Then what was good in that representation, vector representation, if you had an operation where you wanted to replace an element, that was very good, or retrieve, that was more common, then you should use vector. Dynamic is when insertion happens at the end as usual, as a special case, and you want to double, that is insertion offers at the end very often, then you do this. So, the list ADTs are represented using, so now list ADT, array representation and types of lists. So, list ADTs are represented using arrays when the operation of the lists that are frequently needed are retrieval and traversal, not insertion and deletion, because in any of the array implementation, insertion and deletion, general insertion and deletion is very time consuming, whether it be array, whether it be vector, or whether it be dynamic array. In all cases it takes time, it is time consuming, average of the order of n. So, normally when the list ADTs are the operation on the list ADTs are retrieval and traversal, then or even retrieval and traversal, in that case this array is a good representation. Now, when I say retrieval and traversal, it is not that you will not do insertion and deletion, that is where we make an estimate of what is the frequency of operations that can happen. Similarly, the type of list that list ADT represent depends on whether the items are needed in order, or we need items based on some criterion, or how many elements preceded it. So, based on that, that also decides on the type of implementation that you have. So, what did we do in this module? We explained the different implementation of list using arrays, discussed the pros and cons of each implementation, and discussed what are the different operations possible with array based implementation of list. So, we did only the array based implementation of list. In general, for array based implementation of list, insertion and deletion in general is a costly, it takes of the order of n, where n is the number of elements in the list, and whether it be array, whether it be vector, or whether it be dynamic array. But if there are some specific operations that are frequent in those list ADT definitions, then one of these operations with arrays can be recommended as a good implementation of that particular list ADT. So, that concludes this module. Thank you.